Welcome back to the shop and to the channel. In a previous video, I mentioned that I would really like to get some flood coolant working on this Sanford surface grinder. I was given a coolant pump that's in great shape, and I took some measurements to see just how big of a coolant sump I could fit underneath the base of the machine where it's not taking up any more of the valuable floor space in my shop. Based on some calculations that I did, I believe this is about the maximum size that I could fit into the opening in the base of the surface grinder. This is about 16 by 12 inches high by about 10 inches deep. I should be able to take this and, fairly easily kind of slide it into this opening here. I couldn't make this thing any bigger, or it wouldn't fit. But it holds about, I think it's about 5 gallons of coolant. So if this does fit in here, and it looks like it will, it might be perfect for what I need here on the surface grinder. So I started designing what this sump would look like in Fusion 360, considering the size constraint that I have. It's pretty simple to build. It's just sheet steel. Originally designed this probably to be a little bit thicker, but I ended up going down to about 60 thousandths material. But it's the same size as that cardboard box, maybe just a little bit smaller. If I take off the front here, maybe you can get an idea of how this is going to work. So this fitting right here is the sump return. This would be coming from the table on the surface grinder, and it would fall down in this first baffle. And this first area here, this bottom part here, is where all the grinding dust or whatever would end up settling. And then the coolant would feed over this lower piece here, but there could be some junk floating on top, foam or whatever. So the coolant would then fill up this baffle, but it would also come underneath this one because this is not all the way to the bottom. And this is where the pump would be. So the pump would sit in this last baffle and pump its way out to the surface grinder wheel, right? I'd build some kind of a nozzle that would then feed that coolant straight to the wheel. It's pretty straightforward. Not a whole lot of components here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So pretty simple construction here. Dozen pieces. Almost all of them are perfectly square. The only complicated really one is the one here at the top, and I don't even call this complicated, just to have the holes cut in the right location. I could go out and get some sheet steel and cut this apart myself, but I figured I'll give one of these online laser cut places a try, and the one you hear a lot about is Send Cut Send. I've used them before on another project, and I thought the price was fairly reasonable, so I figured this right here probably wouldn't be too expensive. So I'd go ahead and upload DXF files to Send Cut Send and see just how much it would cost to have this cut out of maybe stainless, something like 304 stainless. I'd weld it together, and if not that, just some hot rolled or cold rolled steel. Well, I uploaded the files to Send Cut Send, and $306 for 304 stainless, 60 thousandths 304 stainless. I figured stainless because, it's not going to rust. But yeah, this is just a little bit more than I was willing to spend on a sump for for the coolant. So I decided to try something else. What if I got rid of those? And let's go back to my saved carts, and we'll do the one that's steel. So this is just mild steel. We'll see what this looks like. So mild steel, not much better. Maybe a third or 2/3 of the stainless. Still $220. That's just not going to work either. I do not have a Send Cut Send sponsorship. If I did, maybe I would go ahead and order this and weld it up, because I think it would be a fun project to build this sump to be exactly the size that I want it, so it'll fit. It won't take up any floor space. So I have to explore a different option, and I did. Don't know yet just how it's going to work, but I live pretty close to an industrial surplus reseller, and, well, they had this, and I think this might suit the bill. It's 11 by 11 by 16. It's definitely bigger than what I expected, and it won't fit underneath the surface grinder, and I'm going to have to do some cleanup to it because it is just full of dried whatever this is on the inside. So yeah, we'll see. I'm going to clean it up. I have no idea if the pump works, but I do have the other pump that does work. So we'll see. Maybe I'll use this. Maybe I'll cut it apart and make it fit. It's already on wheels, so I'm kind of inclined just to leave it the way it is and make it work. I only paid about $22 for this thing, so I suppose it's worth the risk. So I'm going to get this thing apart, and we'll test out the coolant pump to see if it's any good. Well, here's why it's only $22. I mean, it is just absolutely packed full of pretty much rusty grinding dust and whatever else is in here. Now, hindsight being 2020, I probably should have just gone and taken this back to the reseller. They do have a 30-day policy, but I have it. Let's see if I can't make it work. I might as well check out this pump, see if this pump's any good. And, if the pump's decent, at least I have a pump out of it. So I'll get this unmounted from the lid and take a look at it. I'm not going to try to clean it up or anything. I might just wire it up and see if it spits out fluids. As expected, it's pretty crusty. Whoever owned this thing obviously never took care of it, or it was taken out of service and sat in a corner somewhere. I'll take this cover off here. It is a 3-phase motor, just like the other one is, and you can wire this up for either 220 or 440 3-phase. It's currently wired for 440, so I'll have to reconfigure this for 220. I switched the wires over from the other coolant pump to this one. Got the phase converter running. You might be able to hear it. We'll try switching this on, wearing gloves just in case. Looks like it does spin. All right, well, that's good. The motor's decent. Let's check to see if the pump's any good. Put this in a bucket of water. I have this setting in a 5-gallon bucket of water, and yeah, the pump is pretty strong. I'm pretty happy with that. At least, if nothing else, I have a decent coolant pump out of this deal for $20. I might as well turn my attention now to this reservoir. I think what I'll do is I'll go off camera. We'll get this all cleaned up. I'll get this junk cleaned out of here, and I'll take it out back. I've got one of those cheap Harbor Freight portable sandblasters. We'll clean this up as best I can, and I'll bring you back when I'm finished. I have this all sandblasted. The lid came out pretty good. I got most of the paint off of it, or at least a good bit of it, and it looks really good. Well, the reservoir itself, not so much. I spent a good bit of time here trying to clean this up, and well, I noticed this hole, this rusted through hole on the side, and an even bigger rusted through hole here on the bottom. I'm not ready to give up on this just yet. I am going to try to weld in some patches and see if I might be able to save my $22 investment. Well, this is probably a waste of time. Well, at least I hope it's not going to be a waste of time. But I would like to give it a shot. I think with as much rust that's on the inside of this thing, it's going to be extremely difficult to weld. But I'm here. I might as well go ahead and give it a try. It's not going to cost me anything to do this, so I'll measure out a patch here for this smaller hole on the side and see what we can come up with for some material to fill it in. Well, this piece of rusty sheet metal will fit right in. It might work. Let me cut out this bad material first. I'll use this piece of square tube. As you can clearly see here with my technique here, clearly you can see how well this plasma cutter cuts, and clearly you'll be able to see right through my gloves. I don't know what I was thinking when I set the camera up here, but anyway, using this piece of square tube as a straight edge, just to make the edges of the patch be a little bit neater. Hopefully it will make it a little bit easier to weld it in. There's quite a larger area here on the bottom where it's rusty, so I'll do the same thing, but I'm just going to create a larger patch. I'll use my pneumatic belt sander here to clean up the edges, get rid of some of that dross. Hopefully get me a decent weld edge. I'll take a little mini flat wheel here to get rid of some of the paint here around the outside of this patch. And I'll do the same thing with the larger patch on the bottom of the tank. I'm going to start with the larger patch here on the bottom. The piece of material I have here has got a few burrs on it. We'll get that cleaned up. I'll wipe everything down with acetone, and then we'll try to tack it in place. Now, I always strive to make my welds look as good as they can be, partly because if it's a good looking weld, it has a better chance of being a good weld. And what I'm interested in here, though, is for this to not leak. And I recognize that the inside of this thing is rusty, and welding to this is not going to be a lot of fun. I'm already seeing some porosity, even in the simple tacks. So these welds might not look gorgeous. They might not even look good. But the goal here is to try to patch this thing from leaking. And if I can make the welds look good in the process, then that's a bonus. Well, I have the larger piece now tacked into place, so I'll flip it over here on the side and fit the smaller patch and get it tacked into place next. I'll start finish welding here the smaller patch, and it's starting off okay-ish. It's not terrible, although I am having a hard time not burning through, so I might have to slow down a little bit. I can try lowering my amperage, but I'm not seeing, a really great puddle here. I think a lot of that has to do with just how much rust is on the inside of this. Maybe sandblasting this a little bit more would have been prudent, but I'm not sure in the end that it would have made that much difference. Well, this is not welding very nicely at all. And again, I suspect it's because this material is very thin and because of the rust and the porosity. I probably should quit while I'm ahead and just throw this thing in the scrap bin, but unfortunately, I'm a bit of a glutton for punishment, so I'm going to keep welding on this thing and see if I can't make it work. I said from the onset I really would like to make these welds look good, but most importantly, I want to make sure they don't leak. And, well, these certainly don't look good. And I'm not sure if they're going to leak. But what I will do is finish welding up this small patch. I will weld up the larger patch off camera, and we'll fill this thing full of water and see how it does. Will I get lucky? Maybe not as lucky as I could be, since I keep dipping my tungsten in this junk. Well, I tried to, again, make these welds look good, and, well, they still leaked. You can see here I've got some paint marker where I noticed some drips when I had this thing full of water. So I could go back and try to weld this up again, but quite frankly, I'd probably just be chasing ghosts at that point. So I think I'm going to try something a little different. Good old Flex Seal. Bought a can of this stuff, and I think what I'm going to do is coat the inside of this thing and see if that won't seal up any remaining leaks. I ended up using that entire can of Flex Seal on the interior of this thing, and it's been curing for about a week. And considering the commercial for that product showed a man in a boat made out of a screen door with nothing but Flex Seal, and it wasn't sinking, I figure, well, it must work. So the little pinholes that I noticed in those welds should be perfectly sealed now, and I should have no issues, right? Well, the only way to find out is to go ahead and fill this thing again with water and see if we get any leaks. Well, you might be able to notice a couple of drips there on the concrete, and yeah, it still leaks. It's only leaking out of the side. The bottom is fine. There's no problem there whatsoever. So maybe I'll get another can of Flex Seal, and we'll coat the inside of it and do a little bit better job on the side of the reservoir here and seal this leak up. Actually, no, I won't. I never had any intention of going any further than this. It still leaks. It's still a rusty piece of junk. It is more than likely going to leak again. And the last thing I want to do is come into my shop one morning and find 10 gallons of coolant all over the shop floor. So I think what I'm going to do here is this is going to go into the scrap bin. I'm not even going to waste any more time with it. It was worth the effort, I think. Maybe I'll keep the handles for any future coolant sump. But I think what I'm going to do is revisit that original plan, except instead of sending anything to Send Cut Send, I think I'm just going to buy some sheet metal. I'll make the cuts myself, and I'll weld it up, and hopefully those welds will be better because it won't be rusty metal. We'll hopefully end up with a coolant pump and a sump that doesn't leak. Well, unfortunately, this week was a bit of a waste of time. But I guess you learn a little bit more from your failures than you do from your successes. Leave a comment down below. Let me know what you would have done differently. But I'm going back to the drawing board. Thank you for watching. Thanks to all those that are subscribing. And we'll see you on the next one.